So when it comes to vectors, the two most important things to know about them are how to find magnitude and how to find direction. And for the direction here, I'm going to give you a little bit of an example, but we have this kind of way of finding the direction. A lot of the time, it is helpful to use the inverse tangent of a value to find this. So I'm going to show you why. The equation is like pretty helpful in knowing it, but really like drawing the triangle and trying to find the direction that way is going to be a much better way of finding the correct angle. So when I'm doing this here, if I am dealing with a vector that is -1, -4, remember that is the horizontal change and the vertical change. So if I were to kind of create this somewhere, I'd go 1 to the left and 1, 2, 3, 4 down, and I would draw my arrow this way here. And so when we are looking for the direction specifically, what we should recognize is a couple of things. First of all, it's helpful to kind of create a right triangle here. And there's two ways that we could draw it. We could either go like on the left side here of my line, or I could go on the right side. It does not matter which direction you draw your right triangle. The only thing that it changes is the way that we are going to find this final direction, this final angle. So I'm going to go ahead and do it this direction here, and then we can talk about how that affects it in a second. I will also, after that, do it the other way in the blue here, and we'll just talk about how we get the same answer either way. But in the red one here, I'm going to look for this angle here first, because I know that this triangle here, I am looking for an angle. I know the opposite and adjacent side, which is why our equation says, hey, we're going to use the inverse tangent, because tangent of this angle is equal to the opposite over the adjacent. And so to find this angle, I'm going to take the inverse tangent of both sides. And when I do that, I'm going to get about 75.96. And that's my angle here, but that's not my direction necessarily, because when we talk about the direction, when we look back at our definition here, we're talking about our counterclockwise angle that it makes with a horizontal ray pointing to the right. That's a really confusing way of saying, like, hey, think about the unit circle. And when we're talking about the unit circle, right, we always start at like 0 degrees here. And so we're saying like, hey, this direction, I'm really looking for this angle in black. And so if I'm looking for that for my direction, I have this angle in red here, which is super helpful because I know this first part of my black line is 180 degrees. So if I take the angle that I have and I add 180, that will give me my direction, which says it's about 255.96. And now that is my direction for this vector. And let's just talk about how this makes sense, right? Because when we're talking about, when we think about the unit circle, right, this is 270 degrees. And so we know that our answer for this one here, since it lands in that bottom left quadrant, has to be between 180 and 270, and 255 lands in that, which is good. And I just want to show you kind of one more work through here to show you why the blue one also works. So first of all, if I was trying to use the blue one here, I would use my components here, 4 and 1 as the side lengths, and then I can again use tangent because I'm saying, hey, tangent of the angle is equal to the opposite over the adjacent. I use the inverse tangent here of 1/4, which will give me 1 divided by 4, about 14.04. And if I'm got this angle here, that's great. But again, my direction is coming from the angle of 0 degrees. So if I know this whole thing, this whole black line here is 270. So if I go here all the way to this dashed blue line, that's 270. But what I really care about is just making it to this purple line. So really what I have to do on this one is I have to take 270 and subtract that blue angle, or 14.04. And if I do that and I plug that into a calculator, 14.04, hey, what do you know? I get 255.96. And so it doesn't matter which way you draw the triangle, but you just need to understand the relationship that it has between 180, 270, 90, and 360 degrees. And if you can do that, then you'll be able to find the direction.